Say we have an incompressible liquid or a solid, that is, an incompressible substance. We recall that our specific heat is approximately equal to a constant volume specific heat, which is approximately equal to a constant pressure specific heat. Recall we can express the change of our internal energy, du, as our specific heat times our change of temperature. If we recall the first formulation Gibbs equations, TdS is equal to du plus pdV. On a per mass basis, ds can be approximated as du per t, for dV is going to be very small in comparison to du. And this is approximately equal to our specific heat times our change of temperature per temperature. Now if we integrate this, ds becomes S2 minus S1, which is approximately equal to our specific heat times the natural log of T2 per T1. If we want to determine the change of specific entropy of copper heated from 20 to 100 degrees centigrade, we can employ this formulation. For us to begin, we'd recognize that we need our specific heat. If we go to table A3 on page 759 of our steam tables, our specific heat of copper is given as 0.42 kilojoule per kgK. Thus, our change of entropy would be equal to our specific heat times the natural log of T2 per T1, or 0.42 kilojoule per kgK times the natural log of 373.15 per 293.15. Notice that these two temperatures are in our absolute temperature scale, and the units cancel out inside the natural log. Therefore, our change of entropy is approximately equal to 0.101 kilojoule per kgK.